Now that we've seen how to reduce finding the area between curves down to a definite integral, which is something we learned to do in Calculus 1, we can say that if f and g are continuous and f of x is greater than g of x on some interval a, b, then the area between the graphs of y equals f of x and y equals g of x on a, b is given by area equals the definite integral of the difference between f and g. And so that should be pretty straightforward. The process involves a little bit more than what it might seem, because you have to make a decision when you're trying to find the area between graphs, which one's bigger, and is it always bigger, because you can't really tell that. And that might require a little bit of algebra, solving an inequality. And the other question is, what are going to be the limits of integration if you're finding the area between graphs, because you'll need to know where f of x and g of x intersect. And that's going to require solving an algebraic equation setting f of x equal to g of x. Then you'll have to do this integration to get the required area and support or confirm if possible. And that, of course, requires a graphing calculator or software, and I'll do my best to show you how to confirm your answers with your graphing calculator. That won't be the hard part. For the most part, the hard part will be finding what integral to evaluate. So let's start with a nice simple example. Find the area between y equals cosine of x and y equals sine of x on the interval from 0 to pi over 4. And you can think about what the graph of cosine of x looks like, what the graph of sine of x looks like on that interval. I haven't drawn it here. Let me take a quick pause and I will draw that. So here's a picture of the region between cosine of x and sine of x on the interval from 0 to pi over 4. I set that as the right-hand limit, so actually is where the sine and the cosine are equal to each other, so I probably could have just said on the interval from x equals 0 to where they intersect. And of course you should see that this is the region we're looking for, this region right in here. And so in order to find that, it's a pretty simple operation. Integral of cosine is sine, integral of negative sine is positive cosine, so we want to find the sine of pi over 4 plus the cosine of pi over 4, and then subtract sine of 0 plus cosine of 0. And so I have an error. Sine of pi over 4 plus cosine of pi over 4 is indeed square root of 2 over 2 plus square root of 2 over 2. So that part's okay. I hope you can see that what I forgot to do was say minus 1, because cosine of 0 is 1. Sine of 0 is 0, so that doesn't show up. So our answer is really all this minus 1, and that means this answer is square root of 2 minus 1. And let's think, that would be approximately, let's say, 4/10. It's a little bit more than 4/10. Does that seem like a reasonable answer? Well, here it's as tall as 1, and it doesn't get any bigger than pi over 4, so pi over 4 is a little bit less than that, and we'd have to subtract off this fairly large area, so I think an answer of about 0.4 is reasonable. I think the answer of square root of 2 was not reasonable. If this was 1 and went all the way out here to 1, then the answer would be 1. Square root of 2 is bigger than that. So obviously I should have been able to figure out that I'd made a mistake there before. So yeah, the correct answer is square root of 2 minus 1. I could have fixed that and not let you see my obvious flaw when I did that. But what I'd like you to notice was that I was able to look at my answer, square root of 2, that I had previously and say, you know, that couldn't be right, because this square that would go all the way out to 1 would have area 1. Square root of 2 is bigger than that. This has got to be less than 1. So I obviously had a wrong answer, and that enabled me to go back and see that, oh, when I put in 0 for cosine of x, I should have written 1 there. So we should have subtracted 0 plus 1, or in other words, subtracted 1. So now you can see that I have the answer correct.